Hello. Yeah, let's wait for 5 minutes, then we can start the session. Yeah, we can start the session. Yeah, welcome all to this week 9 question answer discussion session. So, in this session, we'll discuss some questions related to the power law distribution concept. I hope you understood the concept very well in this week content. And so, along with this question discussion, we'll also discuss if you have any doubts or any queries. Along with these questions, also discuss the concepts related to the particular questions, so that you can understand that particular concept in depth, right? And is there any doubt or any query? Let me know. Free, free. You can ask me anytime. Yeah, yeah. We can start the directly from the questions. Yeah. So in this question, let me read this question. Given a network being generated by the uh, reach get richer phenomena, following figure shows the snapshot of network at time t, right? So this has been given a that figure has been given at time t, right? There is a five nodes. Okay. A new node u enters into the network at time t plus one. right? And makes an edge with one of the existing nodes, right? This is the scenario they have given, right? There is at a t time there is a network, and at t plus 1 time, the next time timestamp, there is a new node has comes into the picture. And that new node has forming edge between the existing nodes, along with the existing nodes. So if probability of p of x is the probability of the new node, right? New node form an second to form an edge with node x. So the p of x represents the probability of a probability for the edge which will be drawn from the that particular node u and existing node from the graph. So considering this scenario, I hope the questions you have understood very well. Uh, and thus, considering this scenario, uh, can you know me the what could be the answer for this question, right? So in reach get richer, there is an preferential attachment scenario has been done, right? So there is an power law distribution like this way. The curve is we are getting, right? Reach get reaches means there is an high number of nodes which has an higher low degrees, right? And low number of nodes which has an lesser degree. So so can anyone answer this question? Yes. Yeah. So here, so what we are so in reach get reacher phenomena, what we are finding actually, so that reach get reacher phenomena which follows the in power law distribution means there is an there is an 2D plot. In this 2D plot there is an a curve we are getting like this way, right? This is in power law distribution which has as x is and 1 divided by k is to alpha. Here alpha is equal to 2 or 3, right? Which is an constant alpha. This 2 and 3 represents the sharpness of that particular uh, curve. So suppose the x is increases, then how much y is decreases. So that defines the alpha, right? So this is 1 divided by k represents a inversely proportional y is equal. So this is an f of x, which we can consider as an y, and this is 1 divided by k, which is an x we can represent as. So f of x is inversely proportional to the 1 divided means x, right? So x represented as an 1 divided by k. So this is one scenario that it's not directly related to this question. So here in this question, uh, in the preferential attachment or the reach get reacher which applies or which obeys the preferential attachment. So in the preferential attachment we have already discussed, if there is a new node it comes into the picture. So the new node connects to a node in the existing graph, connects to the node which has an higher degree, so here so how we can quantify that actually? So firstly we need to um, find their probability. And how we are finding the probability? So let's quantify the degree of each node here. So for this a node there is an 2 degree, B node there is an 3 degree, D node as an 4 degree, right? 3 degree. Degree means which has a number of edges. How many number of edges particular that node has, right? The 3. Here is an 2, right? So these are the degrees, right? 2, 2, right? 2, 3. So So for each degree we needs to, for probability we needs to find out. So probability, why we are finding the probability? The probability defines that how much probability how much probability of being as an age between the that new node and that particular uh, node. Means suppose a, we are finding the probability for the a, means what is the probability this node will connect to a, right? For that we are finding that is a number of how much the a degree has, right? How much a degree has and divided by total number of degrees. So total to how much the summation of the sum of all the degrees, 2 to 4 8 and 3 3 6 at 14, right? 8 and I hope, right, this is in 14. So like this way, so we need to find for each of the node how much the probability associated with that particular node. C D E B C D. So the B has the probability which is an how much probability to connect the B, which is an 3 divided by 14, and C as in C 3 divided by 14, D divided D is equal D is and 4 divided by 14, right? And E has an 2 divided by 14, right? So which node has an highest probability here? What do you think? Which node has an highest probability? So the D node has an highest probability, right? Then he can connect to the D, that is an we can rank here. We connect D, then he can connect to C or B or the second number, because the probability you can see the B and C has the same, right? In between this, then he can that particular this node U can connect to A or E. So considering this, we need to choose the option actually here. So the probability A less than probability D, that is correct. Probability of D is less than probability C. It's not correct, right? This point is not correct, right? Because you can see here the probability of D is very high compared to the C. The 3C is a 3 divided by 14 and D is an 4 divided by 14. So this option is not correct. The second option, which is an A is less than B, A is less than B, that is correct. B is less than D, that is also correct. This option is correct. Let's see the another option is correct or not. Option C, that is the third option. Probability of E is less than probability of D. That is correct. Probability of D is less than. This is also not correct. Probability of A is less than probability C is correct. C is less than. So this is also not correct. Right? So the option here, second option is correct. Right? I hope you understood this solution for this question. Yeah. Is there any doubts? Yeah. If not, we can move to the next question. So this is very simple question that we have already have just for this discussing while discussing the question one, we have discussed what reach get reaches phenomena obeys the which principle, right? And that reach get phenomena is obviously or follows the Fowler distribution, right? So considering that, which option is correct here? It's very straightforward. Anyone? So in polar distribution, we have means we have seen the two distributions, right? The first is a normal distribution, which in that we have seen some examples, which is an that mass distribution or weight distribution of the population, height distribution of the population. We found that we found as a bill shaped curve, right, which is an which represents a normal distribution, normal distribution. And in real world network, these are the examples we can take as an this is it this plot shows for the random graph as well. If you are plotting a random graph by taking a number of nodes and the probability of the means you are taking a NNP, right? For generating a random graph in the previous lectures or previous content, we have seen that suppose we want to generate a random graph. In that case, what we are considering, the number of nodes and the probability, which probability of age, how means what is the probability to create or to draw age in between the nodes, right? So in that case we are taking point 2, point 3, like that way, right? So for that graph, random graph, we are getting as an this like this way, the plot actually. So here in x-axis it represents as an what we can say, it is an degree of the node. And in the y-axis it represented as an number of nodes. uh, so it is an, sorry, this is an degrees actually, 1 2 3 4 5. So this represents, we got, suppose let's take as an example, for 3 we got as an peak value. Peak value means for 3 degree there are a lot of users, lot of nodes are there, which has an 3 degree. Like this way this plot is drawn actually. So in real world, we found that this graph shows like this way. The distribution plot, the degree distribution plot shows like this, means visualized like this way. Here you can take as an degrees 1 2 3 4 5 6, and here are the number of nodes, right? Number of nodes 1 2 3 4, like this way, 1000, right? Number of nodes. So here you can see it represents as an, there are less number of or high number of users, high number of nodes which has a lesser degrees. These are the very low degrees. And there are few number of, these are the number of nodes, few number of nodes which has higher degrees. Here is 100, like this way, right? So how this we are obtaining, we got this plot, because the real world network which follows the preferential attachment, means if node is connected, it's not randomly connected to any node. Suppose the new node comes to into the network, it's not randomly connected to the other nodes actually. It is preferentially connected. Now, preferentially means what? So which the node in the graph, existing graph, which node has an highest number of no highest number of degrees, he can connect to that particular. He is a there is a possibility, higher possibility to connect this node to higher degree node, right? That called as an preferential attachment. Right. So here the option third is correct, preferential attachment. So by following the preferential attachment, we are getting as an that network follows an power law distribution. Right. Yeah. I hope you guys understood the questions. Means reach get it also says that reach gets richer, means higher nodes, higher degree nodes. Suppose the new node says coming into the picture. So and the higher degree node, as in suppose it is, and suppose let's take as an 10 node, 10 degree, right? He has a 10 degrees are there, and there is some nodes are there 2 or is 4, right? Into like this way there. So the new node is coming, so he will connects to this node, right? Possibly most of the time. And then this node's degree is increasing, right? The 11, like this way the another node is new node is coming. So it is also searching or evaluating the every node's degree and finding the probability of connecting to that particular node. So he found, sorry, he finds that he can connect to that particular this node because this node has an higher degree. So it is also increased the degree, that is in 12. That means reach get richer over the period of time. So this like this way this phenomena is obeyed, right? So that is why the preferential attachment option is correct for related to the power law destruction. Okay. Yeah, let's move to the another question, which is question 3. Assume a set of 10 graphs. Okay, there are 10 graphs are there, are generated. These 10 graphs are generated by using Ildos-Renyi model with NP parameters. So what is an Ildos-Renyi model? Which is an that model, which means that model is used to generate a random graph by using n and p parameters. N represents number of nodes and the p represents the probability of age has been drawn in between the nodes. Okay, so that is, and we also saw this scenario in a previous lectures as well. So for drawing or generating a random graph, we are considering the number of nodes n and the p. So it is called calling as an Ildos-Renyi model parameters. So, this is the scenario actually they have given. Considering this scenario, uh, we need to find which statement is correct, which has been given here. Statement one and statement two, right? Uh, so what I will summarize this question, which has we have a 10 graphs. These 10 graphs individually generated by this Ildos-Renyi model, right? Which is the probability for each graph is different, right? So the statement one states that number of edges in all the graphs is the same. So is it true? The number of edges in all the graphs which has this graph has created randomly, which has same. What do you think? Is this statement is correct or not? Yeah, definitely, it's not, because each time, even if the probability is same, suppose the p value is the same, point to point two, suppose in graph one and graph two, there is no possibility to get as an um, the number of edges in all the graphs is same, right? The probability, suppose you are taking the same probability, in that case might be possible, but this is a generated random graph that may be we are that means every time we are getting uh, uh, different ages actually. The statement 2, which states that number of ages in all the graphs may vary, right? So here the option 1 is not correct, because it is saying the number of ages in all the graphs it's same. It's not like that. Every in each randomly generated graph, we are getting a different number of uh, ages, which is stated by this statement 2 actually, right? So at a time, this statement 2 and 1, it's not both correct, right? Because you can see inversely they are contradict to each other, statement 1 and statement 2. The first it's saying that all the number of edges is same, and all the graph has a number of edges may vary, right? So the option 2 is correct, right? So this option definitely it's not, right? There is a possibility only one or two from these two, only two second statement is correct here, right? Which is a very straightforward here. Yeah. Yeah. In the next question, let's see, which has given us set E. In that E set, there is a numbers ranging from 11 to 20. Right, 10 numbers has been given. So there is a task the question has explains, which is that we need to pick a value which is an A1 uniformly at random from this set E. So we have to pick one value from this set, from the E set, and that value which we need to pick by uniformly randomly. Randomly we need to pick that any value. Right? Next, we pick another value A2, right? Again uniformly at random from this set E. Similarly, we pick eight more values A3, A4, like this way 18. So A1 to 18 we have picked randomly 10 values from this set A, right? So considering these A1 to 18 values, look at the sum which is means whatever values we have picked, A1, A2, A3, what is the sum? What is the range of that sum we need to find out here. So look at the sum. S is equal to A1 plus A2 plus dot 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 A10. Which of the following is true for the range of values of S? So this question is directly has been explained in the lecture videos that maybe you understood. Is there anyone want to answer this question? Hello, hello. Yeah. B option. Yeah, B option is correct. So, and can you explain little bit why is the B option is correct? If it is wrong, it's fine. Okay. Yeah. So, the Manish has stated that the option two is correct, but why is that? Okay, let's discuss about that. So, suppose there is an, let's consider two cases, three cases are there, might be possible while picking the random numbers. The case one, case one, in that case, what could be the possibility for each 10 randomly we have picked the numbers from this set, right? There might be possible 11 you have picked in second value you have also picked the 11, that might be possible, right? Like this way, the 10 values you have picked 11 value, that is an smallest value from this set, which is an 11 plus means 11. This is an E1, E2, 11, E3, like this way, plus 11, A10, right? The sum of these values are 110, right? Considering in this case, suppose we have randomly, this is not possible actually, but considering this case, we got as in 110, that is the least value. Less than this value we can't getting from this list actually, right? Let's find a maximum value. What could be the maximum value possible? Maximum value of a summation could be possible, right? So which is in case 2. Right. So the maximum value in the set, which is at 20, at each of the 10 times pick, you have picked the random number from the set, right? So each of the time you have picked a 20 number, like this way, right? 20, 18, A1, A2, like this way. So in this case, in this scenario, we are getting summation of this particular A1 to A2, A1 plus A2 plus A3 up to 18. We are getting summation as an 202, and 20, I mean 200, right? So this is the range. In between this range, we are getting a summation, right? So this is the answer for this question actually. And so, yeah, so there is another factor which from this distribution we are randomly picking the number, so we are getting an bell shaped curve also here, the distribution of the curve. So in the x-axis, the numbers are the represented 11, and this value is actually 110, right? 110 up to 200, like this way. And the this value is a picked value. The 110 is the possibility. This is a possibility how many times this value we have incident. So the possibility of getting this value is very low. Getting this value is very low. Why? Because every time we are picking 11, even 11, that is an randomly we are picking the 11. That is very, it's not true, right? At every random iteration, random picking time, we can consider any. So we will choose any random, any value. It's not like that. Each value is similar, same. The possibility or probability is very low for that scenario. That scenario one and two scenario, case one and case two. Okay, so here the option two is correct, that we have this the case one and case two. That is, we found that minimum and maximum range of that particular. Uh, okay, so pick out the correct representation of the power law distribution. So this is also directly direct answer. Is anyone want to say something or give the answer for this question? Also, I have mentioned in the first slide actually, while we have discussing the reach gate reacher phenomena. In that we have drawn a plot, and that we have discussed f of x is an inversely proportional to the that x, and there is alpha rule of alpha. We have also discussed what is the rule of alpha. Anyone want to say something? So here you can see uh, that considering this considering this plot, we are getting a plot like this way, right? This represent power law distribution, and we have x-axis and y-axis, right? Right. So here represents as an that x, and we have a y-axis as an f of x as a function, right? So for achieving this graph, how we are achieving this graph? That is, an if f of x is inversely proportional to x, right? If this is true in this scenario, how we are getting the graph? In this scenario, we are getting the graph like this way, straight line, because it's not the curve, the sharpness, or the suppose the means the x is increases, 1 unit of the y is decreases, means f of x is decreases, because x raised to 1 is there here, right? That is an alpha we are considering here. That is, sharpness is an very immediately, it's not uh, difference in between their uh, proportion actually. So here the f of x, and here the x, like this way. So we want a sharpness, this sharpness, but there is a multiple sharpness can be possible, right? So considering this graph, so there is like this way sharpness is there, like this way sharpness is there. So which sharpness? So we found that means this curve looks like, suppose the distribution, we plotted a distribution, degree distribution, and we found this like this way curve. But what is the bell curve is required? How much the sharpness we required? how much sharpness which represents a power law distribution, that we need to find, right? So that we have already discussed, which is an 2 or 3. This sharp in between, this sharpness is there, then that particular distribution has follows the power law distribution, and this has been evaluated in the research actually, right? That in real world network, it follows the power law distribution if 1 divided by k, which is an in this scenario, in the present slide, k is an x, 1 divided by x raised to 2 or 3, that represents a power law distribution, which is an 1 divided by x raised to 2 or 3, or in between the values between the 2 and 3. Okay, that represents a power law distribution. Yeah. Is there any doubt to understand this concept? Yeah. So yeah, let's move to the another question. In this question, consider a random graph with 600 nodes and edges between any two nodes with probability point 0.2. Right here we have given n and p, that we have seen in Idros-Rani model, which considers the n and p value to generate a random graph. Where can one expect the peak of the degree distribution of the graph? Right. So we have we know that first of all, this network or this graph follows which distribution? It follows a bell curved normal distribution or polar distribution. Which distribution this graph follows, that we need to firstly understand. Anyone can anyone explain which distribution this graph can follows, this random graph? It is a normal distribution or bell curve distribution, or that polar distribution. So as we seen that Idros-Rani, it follows, which is a random graph generator model, which follows the normal distribution, not follows the polar distribution. So that we are getting as a bell-shaped graph. So it is very bell-shaped graph. Okay. So here we need to find out this value. At which value we are getting a peak? At which value of x we are getting a peak? So here the peak x is degree. Degrees. There are a list of degrees are there, and here the number of nodes or percentage of nodes nodes are there. Here are the degrees. So we need to find out which degree who has a higher number of nodes. Okay. So for that, let's consider a single node from these 600 nodes, right? So we have considered one node, right? N1 from this 600. Okay. So so what is the possibility? How many nodes he can connect? So how many nodes he can connect means how many edges he can establish in between the nodes. Right. So we have given that is an probability of the node he can make edges in between the nodes, right? So we have probability point 2 to make the edges in between the nodes, and how many nodes n1 can consider. So from the 600, we does not consider itself that particular node. We need to consider other nodes or the remaining nodes, which is an 599 nodes, right? 599 nodes. So among these 599 nodes, n1 that is one single node from the 600 node, how many nodes he can connect with this probability. For that, we are simply taking as an product in between this. Right? So after applying this, after doing this, we are getting one something nine something values, right? So which is near to 120 values. So this represent that particular node n1 can n1 can um, connect to 120 other nodes. So this is for a single nodes. We can find for all the nodes we are getting this 120 number. That is 120 represent a degree. Degree means he is connecting, that particular node is connecting to 120 nodes, right? The degree. So at 120 we are getting higher number of possibility of nodes which has 120 nodes, 120 degrees. Right? So here the option 2 is correct. Yeah, I hope this is understand. This is there any doubt? Okay. Yeah, let's move to the another question. In question 7, uh, consider the given graph. There is an incoming node P. The new node comes, right? Incoming node P. Okay. Node P. To which node will this new node be added according to reach get a richer phenomenon? Right. Already we have discussed in question 1, in the first question, how the new node connects to the existing node by considering the rich get riches phenomena. How it is connected? By considering or following the principle of preferential attachment. Right? The preferential attachment states that which node has an higher degree, higher number of nodes, higher degree, that node has possibility to means that new node has possibility to connect that particular higher degree node. Right? Considering that same principle, let's find which node has a higher degree. Okay, so let's start from the 1, 2, 3, 4, 5. Right, this 1, 2, 3, 4, 5. Right, one node has an 5 degree, 7 has an 3, 3, 3, 2, 3, 3, 2, 2. Which node has a higher degree? Which is an node number 1. Right? So that this P is connecting to this node number 1, which is an by considering preferential attachment, which follows afterwards power law distribution. So here option 1 is correct. Right? Yeah, it's very simple. This week assignment questions are relatively simple. So in the next question, let's discuss about the some example, which is marks distribution, student marks distribution example. So which of the following correctly depicts the meaning of marks distribution of students? Marks distribution of the students in class. The first states that plot plot different marks values on x-axis. On the x-axis, there are different marks values are there, and the fraction or percentage of students having those marks on the y-axis. In the x-axis, the marks are there, different marks are there, and y-axis, number of or fraction of or percentage of students who got these marks. Right. So this is one option. This can be represents marks distribution of the student. Let's see the next option. Second option. plot different mark value on the on x-axis. That is fine. We can plot the different marks value on the x-axis, and the percentage of the students having marks greater than those marks. Those marks means whatever the marks has been plotted on x-axis, greater marks who has obtained of that particular students, that those students number of students has been on the y-axis. Right? So it's not related, it's not show or presents the marks distribution of the students. Actually, we need to simply check what is the distribution of the students over the marks, right? Is for 30 or 50 out of 10 marks, out of, so 50 out of 10 marks, how many students has got that 50 marks? Out of 100, sorry. Uh, how many have student has gotten 15? How many students has getting an 20 or 30 marks? Like this way we are getting as an bell shaped curve. So considering this first statement, in the third statement states that plot different marks values on x-axis, that is fine, and in the on the y-axis percentage of students having marks less than the those marks, those means x-axis marks on y-axis. Okay. So it's not presenting explicitly presenting the distribution of the students marks. Actually, it is presenting how many students or has a lesser marks are getting than this plot. Actually, suppose it is in 30, so here the value or value represents on the y-axis, which is an how many number of students who got less than these values. So those count is here. Actually means 10 students who got less than this 30 marks. Like this way third option is saying. In second option it is saying, suppose there is 30, 60, or 90, these marks are there, and these numbers, y-axis number states that suppose the five students has an higher greater marks or greater marks than this 30 marks. Number of five students are there who has an greater than this 30 marks. So it's not representing the distribution of exact marks has been obtained by the students. Actually, in the first plot you can see here, that is, and suppose that is simply it is presenting 30, 60, 90, these are the marks, right? And these are the plot. So these are the y-axis, how many number of users has obtained this directly marks, right? So this way, suppose there is an the curve we are getting like this way. The 60, that is an average marks getting um, students is higher, and there is fail student is very less, and there is topper students are very less, right? So here the option 1 is correct. So like this way, the option 1 represented like this way we are uh, presenting meaningful plot for the marks distribution of the students. Okay. Yeah, let's move to the another question. Assume a random network. Okay, random network means, just imagine that while creating or building the random network, we are considering the n and p value, right? N means number of nodes and p means the probability of age in which been drawn in between the users nodes. Assume a random network of where the nodes were removed randomly. Okay, random network we have generated, and we have removed the nodes randomly, and assume a network b. There is two networks has been given, network a and network b. Network a, in that network, randomly generated network a, we have removed the nodes randomly, and in network b, where the nodes are removed selectively. Which of the statement is true for the results obtained in this demonstration? Understood. Let me recall this or summarize this problem. There is a two random networks has been given. The random network is given, and network A and network B. Right. From this network A, we are randomly from this network A, we are randomly removing some nodes. Okay, and from this network B, we are selectively means what? We are selected the node who has higher degrees. This is how we are selecting the nodes, right? So we are selecting some nodes and then we are deleting them from the network. So the statement once considering this scenario that I have explained right now, considering this scenario, let's find which statement is correct. Statement 1 states that as the network is random, there is a no preferential attachment of the nodes in the network. Yeah, that is true that we have discussed earlier. The random network does not follow the power law distribution. It may gives a normal distribution, which is an bell-shaped curve, right? So this is a true statement, straightforward. No preferential attachment. No preferential attachment, right? No preferential attachment means there is no nodes which has an preferential attachment means the nodes are not connecting to a higher degree nodes, right? Suppose the new nodes comes into the picture, and here this node is not it's not a randomly it's not connected to the higher degree nodes, right? It is randomly connected to any node. That is a random graph generation, right? This is how random graph is work, right? The preparation attachment says that this new node is connected to a higher degree node, that is an preferential attachment, which does not follow the random graph, right? That's why this statement is correct. It is saying it does not follow the preferential attachment. Second statement, there are no hubs in random network. So here the question we have already discussed, what is an hub? Hub means the node which has higher degree, higher degree, right? There is no like that means it is connected to multiple network. Let's we can say that like this way. This is a node, right? And further it is connected to nodes like this way. So this represents a hub. If you are removing this node, then this graph is disconnected. Okay. So this scenario can't happen in the random graph. Random graph, there is no hubs are present. In the real world graphs only, there is an hubs are presented. Okay. So that in this in this week experiment, you have seen that maybe in the implementation session, there is an experiment has been done, that is an you are removing some nodes from the real world network and the random network, and we found that one finding or one insight, which is an while you are removing some nodes from the real world network, okay, real world network, and there is a two methods we have applied: randomly removing nodes and selectively removing the nodes. In the randomly, we are directly randomly removing the nodes, and we are finding at which step we are we are getting disconnected graph. And in selective method we applied a preferential means which node has a higher degree, we have deleted that particular node in first step. Second step, lesser nodes means which has a higher degree, that node we have dropped. And we found that in the real world selective method, in single step we are getting a disconnected network. That means there is an hubs are presented. So one single node is disconnect. Suppose this node we have deleted, which has a higher degree, then our whole graph turns into the disconnected graph. Similarly, this experiment we have applied to a random graph. In the random graph, we have applied two methods similarly. That is a randomly deleting nodes, removing nodes, and selectively deleting or removing nodes. And we found that in the randomly removing nodes and the selectively removing nodes in the random graph, we are getting, or we have a lot of steps to do to remove the nodes. Then we got a as an disconnected graph. There are a lot of steps we need to conduct to get as a disconnected graph in the random graph. Okay, in the selective method also, it gets in multiple steps to turn this graph into a disconnected graph. But in a real world network, we are directly removing hub node, means which has a higher degree node. Then we possibility to get a disconnected graph is very higher. That is one assumption I have given, sir. So, so here there are no hubs in a random graph. That is true. So here statement one and two is two of them is correct. So option three is correct here. I hope this has been understood. Is there any doubt or any query? Free feel to ask me. Okay. Okay. So let's see the last question. Select the correct statement about the Barabasi-Albert model for scale-free network. Scale-free means real-world network. Okay. Nodes are added randomly to the networks. It's not like that way. Sorry, it's not correct. It's the nodes in Barabasi Albert model means it works based on the preferential attachment principle. It follows the reach get reaches phenomena, right? That means in the new node is added, it connects to the existing node by preferential attachment. Preferential attachment means what? The node is connected to which node has a higher degree. That is there is possibility to connect that particular node instead of randomly connected to any node. Okay, so this is not true about the Barabasi Albert model. The Barabasi Albert model it itself that is an model which is an preferential attachment describes, right? It's not different in different model that we have saw, right? How the new node is connected to the existing node by using the preferential attachment, and after preferential attachment it is connected, it follows a power law distribution. The whole process it defines a Barabasi Albert model, right? Let's see the second option. It states that the BA, which means Barabasi Albert model, follows a preferential attachment mechanism. That is true. That we have just now discussed. In third option, all the nodes in the Barabasi Albert model have equal probability of forming connections. It's not like that, right? Where it is follows this equal probability of forming connections in random graph generation. In random graph generation, how it follows? We are giving as an n and p. That p means this probability follows uh, equal probabilities of forming connections in between the nodes. So it is not true for the Barabasi Albert model for the real world uh, graph generation. This is a real world uh, graph that defines preferential attachment, right? In the BA model, new nodes are more likely to connect to existing nodes with higher degrees. That is also true, right? In Barabasi model, new nodes are more likely to connect to existing nodes with higher degree, which also states as a preferential attachment, right? Yeah, that's it for today. I hope whatever questions we have discussed that you have understood very well. Is there any doubt throughout this session or any silly questions if you have? Okay. If not, you may leave this meeting. Thank you for joining. Let's meet for next week.
Thank you, sir.
Yeah. Thank you.